Good day, we are Group 4, and for our database project, my team and I selected Diradec Executive Travel and Tours, a well-established IATA accredited travel agency based in Ghana, established in 2005, and with strong reputation for delivering reliable and stress-free travel experiences to a wide range of clients. My role in this presentation is to provide a brief overview of the company. So, Diradec Executive Travel and Tour offers a wide range of professional travel services, including flight bookings, visa assistance, travel insurance, and customized tour planning and packages. Their operations serve a diverse clientele ranging from individual travelers and students to corporate organizations and religious groups. And we believe that with such a broad service scope, Diradec's operations involve complex data interactions that require efficient organization. Recognizing this, we designed a database system that captures key elements of their businesses, clients, bookings, services, itineraries, and destinations to enhance data management and support smoother service delivery.
I'll be walking you through the ER diagram for our tour and travel company, designed to efficiently handle operations such as managing customers, bookings, payments, destination transport, accommodation, and staff. In our design, we distinguish between weak and strong entities. Strong entities like customer, tour package, bookings, destination, transport, hotels, and employee have their own unique identifiers and can exist independently in the system. On the other hand, we've included weak entities that depend on strong ones for their identification. For instance, Reroute is a weak entity because it relies on both customer and a tour package to be meaningful. Similarly, while payment has its own ID, it is tightly linked to the booking it belongs to. We also have associative entities like hotel package and transport package that handle many-to-many relationships between the package and services. This makes us strong and weak entities help us to model real-world relationships more accurately, ensure data integrity, and the system organized, scalable, and reliable. Thank you.
Our tour and travel ER diagram holds 16 entities, 13 of which are linked by relationships. First is our transport entity, which holds a has relationship with transport mode entity of cardinality 2, which in turn has a has relationship with the tour package entity. Transport entity has a one-to-many relationship with the transport mode through the has relationship, while the transport mode has a many-to-one relationship with the tour package through a has relationship as well. The tour package in itself is involved in a tenant relationship between the customer and reviews entities. The customer reviews the tour package through a weak reviews entity containing both customer ID and package ID as foreign keys. Having a cardinality of 4, the tour package entity possesses 2 has relationships with the hotel package entity and the destination packages entity. Each of these 2 entities mentioned have the package ID as their primary keys, as well as the hotel ID and destination ID respectively, also as primary keys. Both the customer and tour package entities have a one-to-many relationship with the reviews entity through the reviews relationship. Tour package holds a one-to-many relationship with the hotel package through the has relationship, which in turn has a many-to-one relationship with the hotels entity through a has relationship as well. Again, the tour package entity has a one-to-many relationship with the destination packages, which in turn has a many-to-one relationship with the destinations entity. The hotel entity carries a has relationship with the hotel package, and likewise the destination entity carries a has relationship as well with the destination packages. Customer entity has a books relationship with the bookings entity, which is a weak entity of cardinality 2, containing customer ID and package ID as foreign keys. Bookings entity also carries a pays relationship with the payment entity, another weak entity of booking ID and packaging ID as foreign keys. Customer entity holds a one-to-many relationship with the bookings entity through the booked relationship, while the bookings entity itself holds a one-to-one relationship with the payment entity through the page relationship. Having a cardinality of 1-to-1, the department entity holds a one-to-many working relationship with the employee entity, which has a foreign key of department ID. Having a cardinality of 1-to-1, the department entity holds a one-to-many working relationship with the employee entity, which has a foreign key of department ID. Finally are the 3 strong entities: revenues, expenses, and finances, which have no relationships with either each other or other subsequent entities. Postscript: all relationships require mandatory participation except the reviews, books, and pays relationships.
So this is our SQL file, and we are starting from creating our database, which we named the travel and tour, of course, to reflect the kind of organization that we are working with. And just like our logical design, the first thing that we created is the customer relation, which is of course going to be a binary table of many other tables that we have in our database. And one thing we made a change on, in according to our logical design, we were supposed to have the phone numbers of the customer to be integers. Then we realized that sometimes the phone number can begin with a 0, and which can cause some ambiguity. Therefore, we decided to change it to a string character, and that's what we have on this line 16 and line 19. So these are the numbers that we're going to change, because the phone number and the emergency number for the customer relation. Then of course we populated our customer relation. And the next thing that we add is our tour package relation. It's still following our logical design. Nothing much we changed, we just populated this table. Then we have our hotel table. Nothing much change here. We just apply the check to make sure that when the hotel is being rated between 0 and 5 as the values. And of course the rating can be decimal point values. And yeah, we populated our hotel, and then we come to our transport table. Of course, we have we're following our logical design still. We just populated our table, and here are the main corresponding attributes for the transport table. And then here is our destination table, of course, following our logical design, well populated. Then we realized that we had a many-to-many relationship between the destination table and the tour package table, and therefore we decided to break this relationship into a one-to-many using a weak table. And this table that we created, we named it destination tour package to cover the relationship between the destination and the tour package. And of course, going to be a weak relationship being represented by a weak table. And the only keys, the primary key to this table is of course going to be the primary key to the destination relation and the primary key to the tour package relation. And we did the same for the transport and tour package. Of course, there were many relationship here. We changed this, and then of course we did the same for the hotels and the tour package relation. So we also created this weak relation to capture the weak relationship that they had between them. And because we created the tour package and the hotel relations earlier before we could discover this kind of relationship, so it made us have to change or have to create in order to best capture this relationship. And so we have to map the values that we inserted in our destination relation with the values that we inserted in our tour package relation. And of course, this is going to be the relationship is thoughtfully and well captured. And we did the same for the transport and the tour relation, as well as the hotels and the package relation. And here is our booking relation, well populated as well. Also here we have our payment relation, well populated. We also here have our reviews relation, well populated. Then our department relation, and of course the employee relation. So then we have the revenues relation that represent the revenues of the organization, as well as the expense relation that will capture the expenses of the organization and the overall finances of the organization, and which we name the finances table, well populated. Then here come our first queries. So the first queries is maybe to create a new customer profile, which we did earlier on by populating, but of course here we want to show something else. That's why we populated this with true values of customer profiles. Then here we want to update a customer profile, and as you can see, we change the phone number and the email of the customer with customer ID of 5. And of course here we can see we're deleting a customer profile. So these are simple queries for customer. But then we realize that we also have to create a special way of showing essential customer details. And therefore we created a view. And this view is going to capture the first name, the last name of the customer, the emergency number, all the other numbers, and the kind of bookings that they have made, and the status of their booking, as well as the amount that they are paid, and the kind of rating that they're giving, and the summary that they've given us their review. So, and in this case, so we leverage on using the left joins to connect the bookings, the payment, the reviews, and the customer relation, so that we will be able to capture those essential customer details. And from here, if we are to see these essential customer details, and yeah, of course here it's how it will look like. Of course, the customer name, the full name of the customer, their email, their phone number, the emergency number, the passport number, the addresses, the total booking that they have made, the status of their booking, the amount that they paid, the kind of rating that they're giving, and of course the kind of experience that they had. And of course here this is something that to show the general customer details. So we just use the customer table to see whatever it is in the customer table that we have. And of course this is how it is looking like, just following the format of our customer relation. Then also we have to see what we have in our tour packages. So this is one of the functionalities of our database. So we just have to see what is there about in our tour package. And also we wanted to automatically find a way of reducing the number of slots in the tour packages whenever a booking is made. And therefore in this case we try to employ a trigger that will automatically reduce the number of slots whenever a person has made a booking. And of course here these are simple queries to see the number of available slots. So the organization that we are trying to work with has many operations that our database need to cover, and that's why we have many queries as possible. And because of time constraint, we won't be able to explain all these queries one by one. Yeah, but the last two queries like this display the number of employees by their respective department, and the last one display the longest serving employees, as you can see from this display. Thank you.
In conclusion, we have developed a simple database system that addresses the common operation needed by any travel or tour company, and specifically tailored for a day travel and a tour company. However, we did not create a website or an app to simplify the operations such as inserting, deleting, or updating data, and the logical design could be enhanced. Our goal moving forward is improving the integrity of the database through the stronger constraint and further normalizing the data into higher normal form. Thank you.